Hey there, this is Andrew, and today we'll go over the N25 mock paper 1 for AASL. This is question 8. In this question, you're given a function f of x, and you're given that it has two vertical asymptotes at x equals to a and x equals to b. So, part A. The graph of f has vertical asymptotes when the denominator is equal to 0. This is true if x is equal to pi by 2 or 3 pi by 2. Therefore, a is pi by 2 and b is 3 pi by 2. Part B. Let's differentiate f. We have a quotient of two functions, so we'll use the quotient rule. Derivative of the numerator times the denominator minus the numerator times the derivative of the denominator divided by the denominator squared. Cos of x times cos to the 4, sine of x times 4 cos cube of x times negative sine of x. Do not forget the chain rule here. Let's simplify this a bit further. And you're down to cos squared plus 4 sine squared divided by cos to the 5 of x. We want to show that this is true on the interval AB, where a and b are the values that we just found earlier. On the interval AB, cos of x is negative. Just quickly sketch the curve y equals to cos of x, and we notice that between pi by 2 and 3 pi by 2, the function is negative. This means that cos to the 5 of x is also less than 0. Furthermore, cos squared plus 4 sine squared is equal to 1 plus 3 sine squared of x. We know that sine squared of x has to be positive. Therefore, 1 plus sine squared of x also has to be positive. Thus, f prime of x has to be less than or equal to 0 on the interval from a to b. And this also implies that f is decreasing on this interval. Part C. Sketch the graph of f. Pay very close attention to the domain. We know that the graph of f has two vertical asymptotes at pi by 2 and 3 pi by 2. When x is equal to 0, y is equal to 0. Let's actually find the roots of f on this interval. This is true if and only if sine of x is equal to 0, which means x is 0, pi, or 2 pi. We know that it is decreasing on this interval. It is increasing on that interval and that interval. You may take a couple points to double check your calculations. Part D. Verify that f of pi by 4 is 2 root 2. Simple. F of pi by 4, that would be sine of pi by 4 divided by cos to the 4 of pi by 4. Part E. Now we would like to find the area of the region bounded by this line, the y-axis, and the curve. So, where is the line? There's a line. We just proved that f of pi by 4 is equal to 2 root 2. This means that this point of intersection right here is pi by 4. And the region that we're interested in is this part. Therefore, the area is the integral from 0 to pi by 4 of the upper curve minus the lower curve. Integrate, we will get this guy. For the second term, you can use a u-sub, noticing that sine of x is the negative of the derivative of cos of x. You can read of the answer as cos to the power of 3 of x, and then we need to add a constant to it. So it should be, say, a 3 over here. If you're not so sure how you would get this, you can just set up a substitution. So if u is equal to cos of x, the u is negative sine of x dx. Integral of sine over cos to the 4 is therefore the integral of negative 1 over u to the 4, which is 1 over 3 u to the 3 plus c, or this. Now we'll plug in the upper bound and the lower bound. Upper bound, lower bound. Cos of pi by 4, that's root 2 by 2. And you would get this as your final answer. You don't have to simplify your answer any further unless the question asks for it. This is perfectly valid as your final answer.